We're not quite done with the problem of averaging those arrays of grades. So here we are back at the same template that we started from before. We've got the version of the function that just takes a vector of ints as its argument and then computes their average. But this time, I want to be able to extract meaningful information from the exceptions that the function is going to throw. So I don't want to use the standard exceptions in this case because the standard exceptions are mostly useful for indicating that an error occurred, so for example, an out-of-range error, and including a human-readable message, so a string. But if I want to programmatically handle a problem, or I want to learn any information about an error, I don't want to encode that into a string. So we saw in the previous videos that, of course, we can throw an object of whatever type we want. There's no requirement that the objects that we throw be the standard exceptions, like runtime error or out of range or anything else. We can throw ints or strings. Although that's not really advisable because that's a bit of an odd use of the feature, it is completely valid to make up our own exception object, and I've done that here. So here I've created something called invalid grade exception. Although there's no requirement to use capital letters or indeed to include the word exception, I find that not only because I use a lot of other languages where that is a convention, but also because I think it's quite human readable, that might be a good idea. So invalid grade exception is what this function average grades is going to throw if there is a grade in the vector that is invalid, so it's less than 0 or greater than 100. In the event that the array is empty, so you hand me an array, a vector with nothing in it, and ask me to average the grades, obviously I can't compute an average, so I'm going to throw this thing. Now this is really bizarre, obviously. Why am I creating a structure type that doesn't have anything in it? Well, one reason is because I want to give it a descriptive name. I'm deliberately creating a type called empty grade array exception, so that if you ever see this exception get thrown, it's really obvious why it got thrown. And although it's peculiar to see a structure with no members, it is completely valid. You're not required to put members in a structure, and in this case, I'm mostly using this as a convenient container for the name of the type, so that when I catch the exception, it's obvious what kind of exception I'm working with. On the other hand, the invalid grade exception does contain information that I might want outside of the function. So if average grades fails, maybe whoever called it wants to find out why. And so in this case, the invalid grade exception includes encoded into the exception object the index of the first invalid grade that was encountered. So I want to redo this exercise, but throw my custom exceptions instead of the standard ones. So I already have the basic averaging computation as before. If the vector is empty, I'm going to throw an empty grade array exception. So we'll start with that. Okay, so I first ask the question, if my grades array is equal to 0, then, or if the size of the array is equal to 0, well then I want to throw an empty, I'm going to copy and paste this, it's a bit of a mouthful. I can create the object like this, so of course I'm allowed to declare it as a variable and then throw that, as I did in the earlier example. But of course we know by now that for the case of creating exception objects, because you're about to end the function anyway, because you're about to end the scope, it makes more sense to write something like this, where you create an unnamed temporary instance of the object and just throw that. So because empty grade array exception has no members, the initializer, of course, is going to be empty. I'm just using this as a flag to indicate that that was the problem. Now down here, I want to throw an exception if I encounter an invalid grade. So first I'll take a look at the grade that I'm working with, so grades.atI, if that is less than 0, or if that is greater than 100. So in both of those cases, we have an invalid grade. And what I want to do in this case is throw an exception that not only indicates that there was an invalid grade, so that would be the invalid grade exception. I also want to include in that object information about what went wrong. So here I am going to start by actually declaring it as its own named variable. So I'm creating a variable of a structure type. I could create it like this, and then go in and set the member grade index to be the index that I'm working with. So here, this index I is the location of a grade that is invalid. So I could set ex.gradeIndex to equal I. And then I could throw that object. I'm actually going to work with this. Now, we'll see. I'm going to come back in a minute and redo this to be a one-liner, but I want to really emphasize that these throw expressions are just throwing regular objects of regular types. Okay, so I now have, I'm throwing an exception if the vector is empty. I'm throwing the exception if an invalid grade has been found. And so I'll go down here and add some catch blocks to handle those exceptions if they occur. Okay, so the first catch block is going to catch, I'm going to copy and paste it again. It's going to catch one of these. And although you don't have to, I'm going to choose to catch it by reference. It's a good habit to get into. There's no real reason not to catch something by reference, in the context of this course at least. And then I'm going to catch this invalid grade exception by reference as well. And we've seen all along that, of course, we're allowed to give a name to the exception that we catch so that we can then use it. Now, for the case of the empty grade array exception, that's not very exciting because there's nothing in there. Let's see. So we can't compute an average of 0 things. And then down here, let's see. So I received an invalid grade exception, which contains information about a grade that's invalid. So I could actually now tell the user what went wrong. The grade at index, and then I print out the index, so e.grade index, because e is going to be a variable of type invalid grade exception. And then I'm actually going to print out the grade that was that created the issue. So I'm going to print that out in brackets. So grades1.at e.grade index. Actually, you know what I'm going to do is for the sake of this example running more cleanly, we're going to make a copy here called G. So I'm going to start by copying my array grades1 into this vector G, and then I'm going to pass G into my average grades function. That way I can switch arrays much more easily. I'm also going to use 2 lines of output so that it doesn't run off the edge of the screen. And you might be able to see how this could be generalized to not only, throw an exception if the grade is invalid, but throw separate exceptions or encode different information based on the problem. So if it's negative, if it's too large. And of course, because we're now creating our own structure types, it's up to us how much information that we encode. Okay, so I'll try that out. We'll save the file first. So that's the best compile error I can ever expect to get, is the one where I forgot to save my file, because it's an easy fix. So I save the file, I compile it. It did compile once I remembered to save. And I try running it, and of course I start with this array grades1, which has only valid grades. So we'll now we'll work with grades2. We'll copy that into our array G. And we can see in this case, it is able to catch the empty grade array exception and then print out that the list of grades is empty. And then finally, we'll take a look at what happens if we use grades3. So notice that the first invalid grade appears at index number 2 here. Let's see, we actually have to save the file and recompile it. So I need to remember to save my files these days. I was doing so well earlier today. There we go. So in this case, I run the code and it prints out that the grade at index 2, and then it prints out the actual value of -80 is invalid. And just to prove that we could have other, so let's try a grade of 187 and then put some valid grades after that. So in this case, the only invalid grade appears at index 3. And we can see it's printing that that is invalid. So by using my own exception type, I can choose what information to send back. In this case, it's a very simple example, so all I'm sending back is an object containing one int. You might be wondering, why not just throw an int? And there are a few reasons, one of which is, how do we know what that's supposed to mean? Is it an invalid grade? Is it something else? But also because, again, we have this convention that the name of the type that we throw, tells us what kind of error occurred. And only if we're interested, we can probe inside that type to look around for information. So throwing an int doesn't really imply anything about the type of error, so it would be considered a little bit sloppy to do that. Instead, if we want to send back information about a particular error condition, we make our own structure or use a standard exception and include in that structure whatever data we want the caller to find out. So if they would have been interested in knowing the index of that invalid grade, we put that in the structure, and then the caller, if they catch the exception, can choose to use it or not. And as I said, one thing you might want to try with the posted version of this code is to see what happens if you develop the error scheme further to have maybe a specific exception that gets thrown for a negative grade, or an exception that gets thrown for a grade that's too large, or deal with cases where more than one grade is invalid. So in this case, this array now has 2 invalid grades, and if we run it, We will see that it still only prints out that the grade at index 3 is invalid, because the way we've written it is that it throws the exception as soon as it finds an invalid grade. One development you might want to try of this is have the exception object contain a vector of all the indices of places where things went wrong, and when the exception gets thrown, include indices of every invalid grade and not just the first one.